YouTube channel, there's a newsletter, a little bit of everything, and I've been doing Elixir for a number of years. So it's very nice to be invited to speak at these things. So thank you to Elixir Community Krakow for inviting me. So what you're getting now is the developer preview of my talk for ElixirConf EU. You get the first version before it's entirely ready, and while it's still new and exciting, before I remove any of the spicy bits, and before I've ironed out all the bugs. So you'll be able to tell anyone in the community that you saw the talk before it was cool. Now, let's see if we can move one slide forward. Perfect. So a little bit of background about me. Since the 90s, I've been trying to get computers to do what I want, and that's when I first started programming. I got internet access and I learned how to do HTML. I never went into computer science. I'm entirely self-taught, and my learning has always been driven by wanting to build things. I joke about having tried to build a button since 1996, and that's mostly true because that's about when I learned some C++ and then quickly quit when I realized the book went into like classes and objects instead of telling me how to put a button on the screen. So when I found HTML, that was much better. That was much more satisfying, very visceral. I can put things on the screen easily. So I've always had to mix technically interesting work that sort of scratches the intellectual part of the brain with visually interesting work that feels tangible, as far as software can feel tangible. Things you can click, things that react. So theory is clearly not my strong suit, and while I enjoy some good like computer science and theory, I'm driven by making things real. So implementation, that's the name of the game for me. And as I've stumbled around building whatever tickles my fancy, I have run into things that are just frustratingly hard to do. Usually when a project is just about to get really cool, it also gets really, really difficult. And that could be because cool things are just naturally hard to do, or it's the reverse, that things are cool because they are hard to do. I'm not quite sure which is which there, but I do want to make cool things, so I keep running into difficult problems. And that's the thing. When you're executing on an idea, there are always new problems, new trouble to get into. Next slide. To do something that's cool, I think you need kind of interesting input or a method for generating some kind of input. And then you typically need to transform it. And finally, your software needs to produce a different but also interesting output. Many combinations of inputs and outputs are kind of not cool anymore. So that's because they've become normal. So building web forms that capture input, store it in a database, and then list it again in a web browser, that's not really cool anymore. We call it CRUD. I mean, it's not the acronym for cool things. If you actually dig into what it does, of course it's cool somewhere under the hood, but it has no novelty to it at this point. It doesn't challenge anyone's thinking, it doesn't explore new inputs, it doesn't do any neat transformations. The output is dull and expected. And I will admit, this is not a good personality trait necessarily, but I hunt for cool because my brain just craves novelty. Slide forward. Slide forward. Sweet. So this leads me into Elixir. Not because Elixir is a novelty anymore, but rather because Elixir has fantastic abstractions for dealing with a variety of inputs. It manages all the normal ones fine: webhooks, API requests, files, web forms. But I've also tried doing raw keyboard events, USB HID devices, chatbot messages, Raspberry Pi hardware, just to name some of the stuff I've tried. And kind of the basic job of pulling an API has never met a more helpful abstraction than the gen server. Determining if there's new data, something to react to from a REST API generally means you try requests over and over again and hold some states to figure out if something changes. You don't necessarily want to bring in a full database with full full-on validations and persistence just to do that. And the Gen server enables lighter solutions and a lot faster prototyping. So we can also skip adding a special queue system like RabbitMQ or Redis. We don't need a special worker process at the OS level. Just the Beam virtual machine provides everything we want. And Elixir makes the Beam easy to wield. And if we bring Phoenix into the mix, that brings PubSub, which simplifies communicating new inputs to whatever process is interested, to whomever it may concern. And inputs are only really fun if they have outputs. And here we've been given the great gift of LiveView. It makes it trivial to make a UI that reacts to new information where it was previously absolutely doable, but it was so annoying, and you had to bring in a front-end framework and sort of coordinate that and build contract layers. Super annoying. And LiveView instead is just an extremely fun output to work with, especially if you already know HTML, CSS, and the occasional JavaScript, which I do from all my web shenanigans instead of C++. Light forward. There are also other fun inputs and outputs to explore here. Erlang has WX for cross-platform native UI. It has like Elixir brings Livebook for interactive code notebooks. Nerves brings you sensors and hardware, and Nerves Livebook brings both. I've done experiments with a bunch of them, probably all of them at this point. And for example, chatbots are an interesting UI paradigm as well that's really accessible from Elixir with Telegram, Slack, or Discord. Just a few other projects I've built recently. For example, this calendar gadget, as I call it, rather this way around, which is an e-ink screen on top of a Raspberry Pi Zero, which will pull my Google Calendar feed in iCal format, parse it, figure out what's the current events, show it. Also every now and then. There's nothing fancy about it, but it's actually practical. I've also toyed around with this, which is a macro pad, also Nerves, also a Raspberry Pi. And I use that to control the lights in my office for a long time, just over Wi-Fi. Recently, and if you've followed what I do online, you might have seen this. I've played around with this. So this is the USB hid device I mentioned. So this is Stream Deck Plus. You get 8 buttons, which all have screens on them. You get a small touchscreen strip that you can also send things to. And then you get these nice physical tactile knobs, which I can use now to adjust the lighting in my office. I can just turn it on and off if I like. And I drive all of that from Elixir. I wrote a blog post on it if you want to check it out. That's the kind of stuff I find fun, engaging, and cool to explore. I also have built a few Telegram bots because I like the API and I like what it can do. For example, I have used Telegram bots for calling machine learning models, at that point through Python, and I showed some of that off during ElixirConf Africa last year. I just, like last week, built a small Telegram bot for my wife so that she can pull some reports that she needs for invoicing. And that was actually just a practical matter because it didn't need a cron job, and I just needed a way for her to trigger it. It runs on my local machine. Sometimes it's practical. Another practical one I run is a LiveView app, which just pulls all the Nerves-related projects from GitHub, just all their releases and updates, and summarizes that and helps me build the Nerves newsletter, which I publish. So there's a variety of things you can do, but it's all essentially inputs, transformations, and outputs. Next slide. What does membrane bring to the table? So I titled this talk Lively Membranes. If you've done audio or video on the web, you're probably aware that those are some opaque and annoying formats. You need to bring in FFmpeg to do almost anything to them, and you end up Google smithing your way to like this ultimate command line wizardry line, which you just never modify after that. If you need to change it, you'll just get an entirely new one. Like FFmpeg is cool, it's very powerful, it's incredibly flexible, it's a great piece of software in many ways, but it's also really opaque and frustrating. It's not easy to work with. And that's probably mostly due to the formats it works with. Like video is not easy. It's actually hard. Which is one of those cool problems. But Membrane breaks apart the wizardry into discrete components. And then you can pipe them together and you can operate on them in a manageable way from Elixir. So it takes a traditionally very difficult medium and makes it not trivial exactly, but workable, simpler. You get to perform your operations from Elixir. Membrane will, when needed, work with FFmpeg or weird libraries through NIF bindings. But the intermediate steps are all under your control, and you don't have to shell out to anything. And perhaps most importantly, the process of processing media becomes accessible in Elixir. And that is a major source of fun inputs. So you can work with things like time elapsed and progress. You can measure and indicate audio levels, even creating waveforms. You can dig into bit rates, sample rates, channels. You can slice out thumbnail images, split media streams for preview. You can delay, you can bleep. And then you can output as a file, a live stream, a transcoded output, or pretty much anything else. You have a lot of options at that point. When you have the inputs available to you, the rest is just a matter of creatively applying them. And that's, to me, the fun part. The Membrane provides inputs. They call them sources. It provides outputs. They call them sinks. It also provides transformations, and they call them filters. Next slide. Next slide. Oh no. It's going to move again. Previous slide. Fingers crossed. Yes. Let's talk about transformations. Inputting something and outputting the same thing is mostly useful if you're shuffling data around. A lot of the time, you want to combine multiple inputs to synthesize a new, more interesting output, or in some cases, you want to make something available where it previously wasn't. You take your calendar feed, you filter it and mangle it to find the current events, and then you turn that into some text, which is then turned into some kind of pixel drawing that you can then send to a small screen like this one. Some transformations are quite easy, taking an image and shrinking it, taking some text, cutting it down to fit, even taking some text and creating an image with that text on it is something that's offered by a variety of tools. If you are doing transformations with images though, look at the image library in Elixir. It is wildly capable. I've had tons of fun with it with Stream Deck. Membrane lets us transform audio and video, and those are challenging, as we mentioned, and it lets us do it in some interesting ways. It's particularly good at getting you the metadata and at transforming from the necessary inputs to the necessary outputs to enable live streaming, which is extra complicated. But live streaming is what it was made for, after all. But it is also useful for many other things. Now, a brief aside in the next slide. There's a new kid in town when it comes to transformations. I'm not a big machine learning enthusiast. If anything, a little bit of a skeptic. But there is some undeniable utility in some of those models. And that in that weird world of math, some really messy formats, such as human speech, can be transformed with a useful degree of accuracy into text. Automatic transcription is something I find incredibly useful, and it offers a lot of potential possibilities. Machine learning also allows a bunch of other transformations like OCR to turn text into text in images into actual text. It also allows face detection to help you focus on the relevant parts of an image, or to apply effects to faces, of course, like bunny ears or whatever you want. Amusingly, just recently, it also allows text to be transformed with very low accuracy into pictures. I don't think anyone has missed Stable Diffusion entering the scene, and whether that's useful, practical, is really up for debate, but it does fundamentally do text to image transformation in a very novel way.
Now, machine learning is complicated, and it requires a fast language, it requires fast tools, and it requires a bunch of math to get anything done. That's why the pre-trained open source models are typically the most interesting to people like me. I just want to build stuff and try using this. And I have run a few of these models by shelling out to Python. Not the smoothest experience. It does work though, and if there's a new model in town, you can always try it that way. But this is where Bumblebee comes in. Bumblebee takes the promise of numerical Elixir, NX, and it provides models that are ready to use in an API, which spares me from all the math. It also eliminates all the other work, and it eliminates the entire Python tooling. I did Python for years. I'm still happy to be rid of that. With the initial release of Bumblebee, they launched with Stable Diffusion GPT-2 as the big ones, and then a variety of neat, smaller, probably models for things like sentiment analysis of text. In this talk, I'm using what I believe is still an unreleased implementation from Bumblebee's main branch of OpenAI's model Whisper. And that does audio to text transcription, as you might have noticed. It is the single most practically useful model I know of. As someone who records a lot of podcasts, being able to generate transcriptions is like witchcraft. I should also mention Evision, the OpenCV bindings project that Coco put together for Elixir, which also offers a bunch of pre-baked computer vision models for use in your Elixir app. It's also super convenient. Next slide. The wild thing about building experiments like this in Elixir and Phoenix is that you can keep it all in your Beam application. I use no extra infrastructure for all of this. Sometimes I need to put it on a server to make it available, but that's it. I'm doing media handling, and it's well abstracted, it's flexible and powerful. I'm doing machine learning, well abstracted without needing to know one bit about what I'm doing. I'm doing soft real-time web UI, well abstracted with very little effort. And I get standard means of communicating, coordinating between the components of my application, between all these inputs, outputs, and transformations through message passing, just the Beam things. These tools are making hard things easier. And that makes them tools that push the boundary of what is cool and challenging. You can see a cool startup like Supabase sell the capabilities of Phoenix as a product to ecosystems where real-time is actually challenging. That's good for them. That's a nice business idea right there. And if you haven't caught on to it quite yet, this entire presentation is, of course, a LiveView application, a Beam application. It's a mashup of inputs, transformations, and outputs. No particular part of it is very complicated. It's just all about capturing a bunch of inputs, applying some useful transformations, and trying to make the outputs as fun as possible. We can unpack this presentation a little bit in the next slide. So what are we doing? We are measuring audio levels using Membrane, and we use that to produce a waveform that you see here in the background. Hopefully you see it. Otherwise, this presentation is losing something. It just draws an SVG. And I love playing around with this functionality. It was also, ironically, one of the most tricky things to get right, just from a visual standpoint. We also do a near live transcription of what I'm saying. Actually, we're doing two. So one low latency, poor quality, but near instant transcription, 1 second at a time. And then another slower, but better transcription using a 5-second chunk of time. And as we produce the transcriptions, we also take advantage of the transformation from audio to text and look for particular commands. This gives us voice commands that I can use to control these slides, as you might have seen. For example, I have the command clear screen, which resets the transcription, it resets the audio levels, and then it keeps streaming. This is just a mix of parlor tricks and things that look fancy, but it's bundled up with some things that I think are genuinely useful. And fundamentally, I would just love it if you all leave this presentation with some sense of possibilities. Almost anything can be an input, there's a surprising amount of possibilities for transforming inputs, and there are a lot of interesting ways to output things. The trick, I think, is to creatively bash things together and build just a muscle of creation, a habit, practice, get some skill at putting these things together, and that really, really opens up the limits of what can be done. Now, that's it for me. I am open to questions about how any part of this works or what I've tried with this. I'm happy to discuss any part of it. Hope it was interesting.
Thank you very much. Yeah, we have some time for question. I was made aware that probably that might not be hearable, audible on YouTube. So that's just another reason to join us live next time. All right, guys. Who has a question for Lars? Are there any questions here? Okay, here's the first one.
I am not hearing any audio so far.
Hello, can you hear me?
Yes, I do.
Yeah, so my question is like the code available anywhere? Like I'm talking about, you know, displaying this audio, having all this text appearing on the screen. And if you could give us a quick glance, I would really appreciate it. Like,
Yeah, sure. I'll drop this share and just share a code editor instead. Let's get into some business. Yes, everything is available on my GitHub, so github.com/Lavik. The entire presentation is available there. I prefer if you don't give it, but take any code you like. Actually, if someone wants to remix the presentation, I'd be curious to see how that goes. I'm not too particular about it. So this has been some of what I've been hacking on, and this is a very, very messy project. It's literally one live view, one membrane pipeline, a separate membrane library for some of the transcription work where I just built some utilities. There's an NX serving or a Bumblebee serving thing. No, wait, that's just me exploring NX. Never mind. But essentially, it's a live view. This is the state it keeps. It keeps a reference to the pipeline. It keeps a list of transcript entries. It keeps the instant transcript separately. It keeps a bunch of levels, and it's a map that matches up with transcript indexes. There's some reasons to do that, but it's mostly to avoid pulling in too many of the level samples. There's a counter for which slide I'm on. The actual sliding is just a JavaScript library I pulled in reveal.js because that's not what I wanted to build. And I don't think I even used these two. Those are leftovers. Here's some leftovers from me experimenting with it on a machine where I couldn't get the microphone input to work, so I just had fake data so I could do some design experimentation on it. But things like I'm grabbing certain things that Whisper will output if I'm not speaking for a bit. This will it will output silence, 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 and I just map those to nil and then filter out all the nils. Similarly, keyboard clicking, blank audio, typing. But there's nothing fancy here because all I'm getting is text. Once you have the text, it's not particularly difficult. It's just like how do I detect a substring in a text? It's not that difficult. If string contains go to slide, there's absolutely nothing smart going on here. So there's that, and then there's the pipeline. Hold on, I need to look behind my camera to actually. There we go. And this consists of, well, it can switch between a mic and a file input. In this case, I'm running off of a mic, which uses the port audio plugin. Then it's an audiometer, the converter, which just makes it a known shape, so float 32 low endian, because Whisper likes those. I timestamp them with a special element I built for that. And then I do the quick transcription, which is a buffer duration of 1 second. And then I use the other transcription, which takes, well, this is 5 seconds, but it's variable. And then I actually just dump the data. I don't keep it around. I put it in a fake sync. I link all these up. I handle some notifications. So I've set up Whisper to send me membrane notifications when it completes transcripts. So I get these and I broadcast them, and the LiveView picks them up. There is absolutely nothing particularly weird going on here. Like, the weirdest things are building SVG draw commands and counting bytes. That's about it. So that's a little bit of the code, but everything's available on GitHub. The transcription, membrane library, and this entire presentation. So go for it. It's called Lively. You'll find it.
Yeah, great stuff. Thanks.
So my question is, because it seems you bridge like really a lot of various tools, and the question is if you had any particular difficulties with like joining this all together and with reasoning about all this stuff, or it just went smooth and it just like it looks like here.
It was definitely programming, so it was not all smooth. Doing some of the trickiest things was just, for example, chunking the audio in a way that was useful to Whisper. So Membrane already chunks things into buffers of what it considers appropriate sizes. I may even be able to configure that in some way that I haven't explored. But I built an element that essentially captures a number of seconds of audio, sends that off to Whisper. It always passes the audio on. It doesn't wait for anything. So you get the transcript as soon as possible. And the audio pipeline keeps going as fast as it can. But that meant I needed a strategy for sort of how do I figure out where I am in the audio if I want them in a particular order and if I want to know when it starts and stops. So one of the things I'm doing is I'm actually showing which second a particular transcript starts at, because that's something I wanted in the presentation. But essentially, once you realize like, oh, wait, I'm actually giving it a very consistent shape here. These are 32-bit floats at a known sample rate of 16,000 hertz, so 16,000 samples every second, and a single channel. Then I know how much data is actually in a second. So then I just have to watch, okay, have we captured that amount of bytes? That means we have 5 seconds, send it to Whisper, move on. And that bit took me, like before I realized how simple it could be, I tried a bunch of things that did not work very well. So that was probably the trickier part. But the really difficult work has been done by the Membrane team, by the people that do Bumblebee and provide me with Whisper in a way where I don't have to use either Python or FFmpeg. So no particular difficulties with like making things work together once I've wrangled the data correctly. And I think that's one of the challenges in Membrane, like getting the format you need and figuring out how to use it well. Because most of us don't think in audio and video pipelines.
Thanks a lot.
Okay, are there any other questions? I don't see anything. Yeah, okay. So thank you very much, Lars, for joining us.
My pleasure.
And hope to see you in Lisbon in April.
Oh yeah, head in there. We'll see what this talk looks like at that point. I think I might have gotten a few ideas. Actually, if you have ideas about what should be mashed up or something you'd like to see, feel free to reach out at Mastodon or email or wherever. I'm pretty available. Elixir Slack works as well. All right. Thanks for listening.
Thank you very much.